Hello everyone, so welcome to my YouTube channel. So guys, welcome back after the midterm examination and after the Deepavali festival. So we are again going to continue, and the thing is now you are having the first year 11th student. Now you will be having the what? Yes, final examination. In the month of February you will be having the final examination. So in the final examination, as you know that all the chapters are coming in the examination, so that's why we have to focus on all the chapters. Okay, so what we are going to do, we will complete all the chapters over here. Okay, we started with thermodynamics and we are going to complete all the chapters of the NCERT. And very important thing is, if you want to get the video for this thermodynamics, where you have to go, you go to my channel. You go to my channel. In the channel you go to the playlist. In the playlist you will get the playlist of thermodynamics. You can go there. Okay, you will get according to the video 1, video 2, video 3, video 4, like that. Okay, so in today's video we are going to continue from enthalpy. Okay, see the word enthalpy. If I will talk about enthalpy, if the word enthalpy will come, the first thing will come in our mind is nothing but heat content, total heat content. That's the simple thing. If anyone will say about enthalpy, that means that total heat content. Like another word is there, entropy. If anyone will say entropy, okay, entropy. So if anyone will say entropy means what, the thing will come, the first thing will come in our mind. Entropy means randomness, right? Randomness. So in which randomness is more? Gas. In gas, right, the particles of gas is having more randomness. So the word entropy means randomness. So that's why the word enthalpy means, enthalpy will come means total heat. We are talking about total heat content. Okay, so we'll write the definition. Okay, so enthalpy is what? Enthalpy is a thermodynamic property. So it is a what? It is a thermodynamic property. Okay, enthalpy is what? Enthalpy is a thermodynamic property that represent the total heat content, that represent the total heat content of what? See, in thermodynamics we will talk every time about the system. We don't care about the surrounding. So that's why enthalpy is what? Is the thermodynamic property that represents the total heat content of a system. Total heat content of a system. And very important thing, at constant pressure. Because here we are just talking about the total heat content. Okay, that's it. At constant pressure, we are not going to change the pressure. The pressure is remain constant. Okay, fine. So here the formula for enthalpy, enthalpy is denoted by H. Okay, see how the formula will be. Enthalpy H equals U plus PV. Okay, so enthalpy is equals to what? U plus PV. Okay, H means enthalpy. See, enthalpy means what? Total heat content. So whenever you will take the total heat, means total heat content means what? We will take the heat, the system will absorb the heat, right? So if the system is absorbing the heat, what will happen? Yes, joldi. Yes, if system is absorbing the heat, so what will happen? The temperature will increase. So if the temperature will increase, what will happen? The particles will start moving in random motion. So what will happen? The internal energy of the system will act, right? Internal energy of the system will come into action, because the particles will start moving. The movement is what? Kinetic energy will come. With that, potential energy will also come. Why the potential energy will come? Because when the particle will start moving inside, okay, like here, This is the system. This is the system. Okay, so what will happen if you will take the heat? If you will take the heat, what will happen? The temperature will increase. The temperature will increase. So what will happen? The particles of the system, will start moving randomly, and they are start hitting each other, and they are start hitting to the wall of the piston. So what will happen when the particles are start moving in random motion? What will come? Kinetic energy will come. And then when it will start hitting the piston, what will happen? The piston will move up. So this movement will bring the potential energy. So kinetic energy plus potential energy is what? Internal energy. Already we studied. So internal energy plus constant pressure. So pressure, and see here what will happen if this piston will move up. So there is a change in the volume. So that's why it's a V. Okay, this is the formula for enthalpy. Enthalpy is what? H equals, if heat is coming, so kinetic energy will get changed because the particles will start moving in random motion. With that, potential energy will change. So kinetic energy and potential energy will change, means it's called internal energy. We studied before also. Kinetic energy plus potential energy is what? It's internal energy. So internal energy plus, here we are talking about pressure. Pressure into what will happen? If this piston will move up, means change in the volume. So volume will also come. So this is the formula for enthalpy is equals to H. Enthalpy equals U plus PV. This is just the formula of enthalpy. It's not the change in enthalpy. Okay. If we will write about change in enthalpy, change in chemistry, change is denoted by delta. In chemistry, if I'll talk about the delta, that means change. Okay. And which change? This change is dependent upon the final value minus initial value. This change value is what? Final value minus initial value. Okay, if you talk about change in enthalpy, so change in enthalpy means delta H equals change in internal energy plus constant pressure P into change in volume. Okay, so change means what? If I will write this, delta H means what? The final value minus initial value. Delta U means what? Final value minus initial value, plus P into delta V means what? Final value minus initial value. Okay, so enthalpy formula is this. Then change in enthalpy formula is this. Delta H equals delta U plus P delta V. Okay, so here we have to understand one thing. See, this is the formula for enthalpy. So what you have to write now? You have to write the definition of enthalpy and just this formula of enthalpy. This formula, don't write this. Okay, this we will derive. This is just for your understanding. I have said enthalpy formula is this. This will be change in enthalpy. So how the change will takes place. Okay. Now next thing we have to write is, why is enthalpy used? This is important question, guys. They have asked in the examination. Define enthalpy and why is enthalpy useful? Why is enthalpy useful? Why is enthalpy useful? They had asked in the question. Okay, why is enthalpy useful? First point is, in chemistry, see, in chemistry what will happen? Chemical reaction will happen. Chemical reaction means what? It based upon the temperature, will change the temperature, right? Chemical, because whenever the reaction is happening, what is happening? The change in the temperature, right? Mostly from solid to liquid, we will change the temperature. From liquid to gas, again we will change the temperature. But from gas to liquid, we will cool the temperature, means we'll less down the temperature. Then from liquid to solid, again we will less down the temperature. So what it's working? Temperature, right? So that's why if you are taking the heat, that is endothermic. So what will happen? Heat, the temperature will increase. When you are releasing, it is exothermic. So what will happen? Temperature will decrease. So that's why in chemistry, what will happen? In chemistry, most reactions happen at constant pressure. Okay, so that's why we will use the enthalpy. The reason behind is what we have seen in the enthalpy. Total heat content of a system at constant pressure. That constant pressure means that's the reason. Why is enthalpy used? Because in chemistry most reaction happens at constant pressure. So in what is changing in chemistry, most reaction happens at constant pressure. So what is changing? Temperature is changing, because system will take the temperature endothermic, so temperature will increase, or either system will release the temperature exothermic, temperature will decrease. Okay, so pressure will remain constant. Second is what? Under, just now what I have said, okay, we are going to write the same thing. Under constant pressure, if pressure is constant, okay, under constant pressure what will happen? The change in enthalpy, change in enthalpy means what? Joldi bolo re. Change in enthalpy means delta H. So change in enthalpy means what? Change in temperature, because enthalpy means what? Heat content. Heat depends upon what? Temperature. So under constant pressure, the change in enthalpy delta H equals to the heat absorbed, or released, by the system. Okay, so you can write this. So again same thing, constant pressure what will happen? The change in enthalpy means heat content will change. So change in enthalpy equals to the, either it will heat absorb, if heat will absorb, so what will happen? Temperature will increase, so change in heat, so delta H will change, or heat released. Heat released means exothermic, the temperature will decrease, so there is a change in the heat content. So that's what he wants to say. Okay, yes sir, fine. Okay, so now write on this slide, important slide guys. Okay, now understand, don't write anything, I will tell you what to write and when to write. First understand. Okay, so now we'll come for the enthalpy, like as we know that. So enthalpy is what? Enthalpy is a state function. How enthalpy is a state function? Because enthalpy is denoted by change in enthalpy, like delta H, right? Change in enthalpy means delta H. So we know that wherever delta will come, delta indicates the what? If I write the delta H, so its value is final enthalpy value minus initial value, right? So final minus initial means it is a state function, it does not depend upon the path. So wherever delta will come, like delta V means final volume minus initial volume. So wherever delta will come, it is a state function. Okay, it's a state function. Oh. Shit guys, shit. It is a state function. Oh, okay, it's a state function. Okay, now we'll see here. Okay, so now see what is enthalpy, like heat absorbed at constant volume. Okay, now we are seeing here the conditions. Okay, we know if we'll talk about enthalpy will talk about its what? It's a, first of all, enthalpy is a state function. Second, enthalpy is what? At constant pressure. Okay, but now here we have a condition. Now we'll talk about the conditions. Now heat absorbed at constant volume. Now guys, see, we are talking about thermodynamics, so we know this formula of the thermodynamics. The basic formula of thermodynamics is this. Keep in your mind, right? We have did before also. We know this basic formula of what? Thermodynamics, which we got from first law of thermodynamics. What is the basic formula? Delta U equals Q plus W, means change in energy. Delta U means change in energy equals what? Q means heat plus work done. Okay, this we have already studied in the first law of thermodynamics. So based upon that, we have to understand now here the enthalpy concept. Based upon that, we are going to understand the enthalpy concept. This is very, very important. Understand the concept. They said heat absorbed at constant volume. What will happen if heat is absorbing but volume is constant. What does this mean? This mean that, see here, this mean that this is a beaker, this is a piston. Okay, this is a piston. So what is happening here? Heat, you are absorbing the heat. Heat we are absorbing. So what is happening? Heat is there, right? We are absorbing means heat is positive. Correct? We are absorbing the heat. So what will happen? Heat is positive. We have studied the sign convention, right? If heat absorbed by the system means it is positive. So what will happen? Delta U is equals to Q. But what is the condition? The condition is heat absorbed at constant volume. See, understand the condition. So that's why I have underlined the condition with green. The constant volume. So see here, volume is constant. Volume is constant means before and after it is same. Means what is happening? It is not expanding. It is not expanding. It is not expanding. So what is the volume is constant? If volume is constant means it is not expanding or it is not compressing, right? It is not expanding or it is not compressing. So what is happening? Volume is constant means what we will say? No work done, right? No work done. If work is done means what will happen? Work will done means either work will done from inside, so it will expand, or either the work is done from upside, so what will happen? It will compress. So work is not done, right? Work is not done. So that's why volume is constant. If constant volume means work done is 0. So here this is the first law of thermodynamics. So no constant volume means work done is 0. So that's why they said here heat absorbed at constant volume is equals to change in internal energy. Delta U equals QV. QV means heat at constant volume. See, we got from here delta U equals QV. This means that we are taking the condition at constant volume. We are taking the condition at constant volume. So that's why this formula came. At constant volume, what is happening? Heat is equals to change in, this change in U means internal energy. Change in internal energy. Understand? So after that, what you have written, okay, means I hope you have written this right. Means here you have written this enthalpy definition until here, right? After that you had written this slide. Okay, after that, guys, no need of writing this. This is just the concept. You have to understand this concept. We had already studied before. So just understand the concept. What will happen when we'll take the heat and at the constant volume and all. So no need of writing this. So what you have to do after writing this, why enthalpy is like important or why enthalpy is useful. After that you can give the arrow wise and you can write. So give the arrow and you can write from here to here. Okay, so what we get to know, heat absorbed at constant volume, which is equals to change in internal energy, delta U. Okay, so now we will see here, next thing, very important thing is, we know that delta U equals Q plus W. Okay, now guys, what we have seen, the before the condition we have seen it at constant volume. Now we will see the condition at constant pressure. Okay, at constant volume, what we have seen, at constant volume we see that delta U equals QV. But now we will see at constant pressure. At constant pressure. At constant pressure means we have to keep the pressure as constant. Okay, so constant pressure means what will become? Work done. Work done will be minus P delta V. Means see here, constant pressure. Pressure means what? See here. Again what is happening? I see here. Again what is happening now? Now we will change the condition. Okay. Now we will change the condition. Okay. Now see here. Now what is happening? Now we are taking the heat. We are taking the heat. So if you are taking the heat, Q is equals to positive. Q is positive. Okay, Q is positive. Now what will happen if you take the heat? Again, right, the particles will start moving in random motion and the particles will hit itself. Particle will hit the wall. Particle will hit this piston. So what will happen when particle will hit the piston will start moving in upward direction. right? It start moving in upward direction. So now we are talking about constant pressure. The constant pressure means what will happen? The pressure remains same. The pressure is not going to change. The pressure is not going to change. So pressure is not changing. So what will happen? If we will apply the work from here, if we will apply the work, if we will apply the work, so what will happen? Work done by the system, it is expanding, right? Work done by the system, it is expanding. So it's expanding means what will happen? Delta U equals to Q, means it will be plus. So now what will happen? Pressure is constant. So here this pressure is constant. Pressure is constant means we are not going to change the pressure. Pressure is constant. So what will happen? If you will apply the work, like, right, we will do the work from inside, we will do the work from inside. So what is happening? Work done by the system, work done by the system, work done by the system. So why the system is negative, pressure will remain constant, but what will happen when work is done by the system? So it is expanding. So there is a change in the volume, right? Either to expand, either it will compress. There is a change in the volume. So change in volume means delta V. So this is the formula will come, right? You can see here. So delta U equals QP minus P delta V at constant pressure. At constant pressure, this Q minus P delta V, where QP is the heat absorbed at the system and minus delta P like work done. Okay, expansion, it is expanding. Understand? So after this, give the arrow and you can write down till here. Okay. Now after that, you see here, this is a very important thing. Okay, now we got this delta U equals QP minus P delta V. As I have said you, delta means what? Final value minus initial value. So this equation, how we can write? Delta U means U2 minus U1 equals to QP minus P into V2 minus V1. Correct? Yes. Why? Because delta means we know final minus initial. After that, we will do rearranging, we will get this. So we rearranging means what we will do? We will bring the U2 V2 one side, U1 P1 one side. Okay, so from here we will get this QP equals U2 this plus PV2 minus U1 plus PV1. Okay, so we know what will happen, 2 minus 1. So that's why we have a minus over here, and then 2 means U2 plus PV2 U1 plus PV1. So we will get this. Okay. So after that, what will happen? After it will continue. After writing this, we will write this. So from here, this equation delta U equals QP minus P delta V, we will get this, because delta U means what? Final minus initial. So U2 minus U1 equals QP minus P delta V means what? V2 minus V1. Then we will rearrange, we will get like this. QP equals means heat. QP means what? Q means what? Heat at constant pressure. Heat at constant pressure means that is equals to U2 plus PV2 minus U1 plus PV1. Okay. So we know that H equals what? We have already know enthalpy means H equals U plus PV. Right, see this U plus PV, U plus PV. So this is U2 plus PV2. So this means what will happen? QP equals, see this U plus PV2. See H is equals to what? H is equals to U plus PV. So if I will write U2 plus PV2, we took 2, so it will become H2. H2 equals U2 plus PV2. Same if I will write U1 plus PV1, I took U1 V1, it will be H1, right? So that's why this will become H2 minus this will become H1, that is nothing but delta H. Okay, so that's why the final thing what we got here is this. Okay. Now see here. First we get to know at constant volume. I have explained you at constant volume what we are getting. See this heat. Q means heat at constant volume, that we get change in internal energy. After that we started this. After that we had started this, right? We have written this delta U value at constant pressure. So constant pressure, what will happen? Pressure is constant, so work done will happen, so that's why we will get this value. So from here we will write the expanded form, and then we had arranged that U2 V2 one side, U1 V1 one side. Okay, then after that this value is what? This value is H2 and this value is what? H1. So we will get delta H. So now what is this? This is heat at constant pressure is what? Change in enthalpy. Okay, now we see, before we got heat at constant volume is what? Heat at constant volume is change in internal energy, but heat at constant pressure, QP, means heat at constant pressure, that is change in enthalpy. Okay, this is very important. So now we know that heat is what? Path dependent function. Heat depends upon the path. So H is a state function. Q is what? See here, Q is what? Q is a path dependent function, but H is a enthalpy, the state function, because it depends on U, P and V, which all of are a state function. So delta H is independent of path, hence QP is also independent of path. So the thing here is, if I will talk about only Q, only heat means heat is a path function. But when we will take the heat at constant pressure or heat at constant volume, then that time it will become state function. Why? Because this here, heat at constant pressure now is directly equals to change in enthalpy. Change in enthalpy. So enthalpy is what? Enthalpy is a state function. So that's why QP will also become state function. And QV is equals to what? Jaldi bolo. QV is equals to delta U. So delta U is what? Change in internal energy. So change is the state function. So QV will also become state function. Change in volume is also a state function. Okay. So means heat. QV means heat at constant volume. So understand one thing. If we will talk about just heat, this they can ask in the examination in MCQ or assertion and reasoning also. If just heat is a what? Path function. But if you will take QP or QV, means heat at constant pressure or heat at constant volume, it will become state function. Why? Because QV, heat at constant volume, is equals to delta U. So it depends upon delta U. Delta means state function, so it will become state function. Same here, QP means heat at constant pressure, which is equals to delta H. Delta H means change in enthalpy. So change will come means QP is a state function. Only heat is a path function, but QP and QV is a state function, because QV is equals to delta U and QP is equals to delta H. Both is equals to delta. Delta means change. Change indicates that it is a state function. So QP and QV will also become state function. Very important. Okay, I hope till here you understand how this delta U is equals to QV came, and this the derivation of QP is equals to delta H. Okay, QV equals to delta U and QP equals to delta H. Now we will see here, we know that this, right? Now see, we have a two formula, this formula and this formula. So this is delta H is equals to delta U. Okay, this is delta H is equals to delta U plus delta PV. Delta PV means here this is not a constant pressure. Why it is not a constant pressure? Because if I will write this, delta H means it will become H2 minus H1. Delta U means U2 minus U1 plus delta PV. Delta PV means it is P2 V2 minus P1 V1. So this is what? This is not constant pressure. It is not constant pressure. Okay, sometime in the examination they can ask you in MCQ, formula of change in enthalpy. Formula of change in enthalpy at what? Constant pressure. If they will say formula of change in enthalpy at constant pressure. At constant pressure, then you will write this, change in enthalpy equals change in internal energy plus constant pressure into change in volume. This you will write change in enthalpy at constant pressure. If they will say change in enthalpy when pressure is not constant. Change in enthalpy when pressure is not constant. So this will be delta H equal to delta U plus delta PV, means expanded form is this. Delta PV means P2 V2 minus P1 V1. Okay. So this is when not means when the pressure is not constant. This is at constant pressure. Okay. So how you have to write it? See, just write on this what I have underlined with this yellow color, then this underlined, this underlined, this underlined, and this one underlined, and then this one underlined. Okay, so these are the like proper notes for you, and I hope you are understanding the thing. Okay, then this, so see, whatever I have underlined, you write that much only. Okay, now this, just give the arrow and write on. No need of topic, because topic already we had given enthalpy. Everything is coming under the enthalpy. So after that, now give the arrow, just arrow, just arrow, give the arrow, just arrow. Okay, just give the arrow and write on. So see, we know delta H is negative for exothermic, right? Delta H means what? Heat content. Enthalpy means heat content. So exothermic means when you will release the heat. When you will release the heat, what will happen? The temperature will decrease, means heat content will decrease. Decrease means negative. So that's why delta H is negative for exothermic reaction which evolve heat during the reaction, and delta H is positive for endothermic reaction which absorb heat. So if it will absorb the heat, what will happen? The temperature will increase. If temperature will increase, what will happen? Heat content will increase. So delta H will be positive because heat is increasing. Now see here, at constant volume, see, constant volume we know delta V equals to 0. Right? Constant volume, what we know? Constant volume we know delta V equals to 0. So see here guys, see here. Okay, delta H is equals to, see this, we know that delta H is equals to delta U plus P delta V. So at constant volume, we will now give the arrow this. At constant volume, delta V equals to 0. If delta V is equals to 0 means P into delta V will be 0. So at constant volume, what will happen? Delta V is equals to 0. So delta H is equals to delta U, right? Delta H is equals to delta U. So delta H is equals to delta U. So at constant volume, what is the delta U? Delta U is C. Delta U is equals to QV, right? At constant volume, delta U is equals to QV. So what will happen? Delta H is equals to delta U. We get to know at constant volume, right? At constant volume, what will happen? Delta V is equals to 0. So delta H is equal to delta U plus P delta V. What will happen? If delta V is equal to 0 means this whole term will become 0. So we have just delta H is equals to delta U. We have just delta H is equals to delta U. But at constant volume, delta U is QV. So we will write is equals to QV. So understand one thing. At constant volume, QV equals to delta U. At constant pressure, QP equals to delta H. But at constant volume, delta H is equals to delta U, and which is equals to QV. Understand, very important thing guys. Okay. Now here, this is again important. Now see that it is same. Delta U is equal, delta H is equal to delta U. This will come delta NG RT. So how it will be coming? We will just seeing it. Okay. Now here, now we'll write from here. VA is what? Total volume of gaseous reactant. A I will take as a reactant, B I will take as a product. So we'll think like that. A, the reactant, it will give the B, which is product. Okay. So VA is the total volume of gaseous reactant. Okay, reactant in the gaseous form. VB is the total volume of gaseous product. The product is also in the gaseous form. Na is the number of moles of gaseous reactant, and Nb is the number of moles of gaseous product. Because we know A we will take for the reactant and B we have taken for the product. All at constant pressure and temperature. So we have kept the constant pressure and temperature. Then using the ideal gas law. Ideal gas law formula is what? Yes. PV equals nRT. PV equals nRT. So for A what will happen? See, we know that constant pressure and constant temperature. So pressure will remain constant. So P volume A. VA equals, we have Na RT. R is a gas constant which will remain constant. Temperature will be T because we have talked about constant pressure and temperature. Both pressure and temperature is constant. So PVA equals NaRT. This is for the reactant. Then PVB equals NBRT. This is for product, because we are dealing about ideal gas law. Ideal gas is PV equals nRT. Now what we will do, we will take B minus A, means product minus reactant. So that's why we will call as final minus initial, because final is what? Product. Initial is what? Reactant. So product minus reactant. PVB minus PVA means this NBRT minus NART. So RT will take the common from here. So NB minus NART. Okay. So P I will take the common here. Then P VB minus VA equals NB minus NART. Okay. So VB minus VA means what? Final minus initial, because final is what? Product. Initial is our reactant. So VB minus VA means delta V. So P delta V equals, see, RT will be here. Now delta, see, NB minus NA. NB minus NA means it is delta N, and then we will write G. Why? Because delta NG we will take only for the gaseous. Only for the gaseous. Like here, delta Ng refers to the number of moles of gaseous product minus the number of moles of gaseous reactant. Means we will delta Ng, how we will find? Delta Ng we will find that number of moles of the gaseous which is present in the product side minus number of moles of the gaseous which is present on the reactant side. Okay, suppose if in the product side, if it is solid is given or liquid is given or aqueous is given, we will not consider in the number of moles of gaseous. In product side, if they will mention the gaseous, then only we will take the gaseous. If they will mention solid, liquid, aqueous, we will not consider. Same in the reactant side, if they will give solid, liquid, aqueous, we will not consider until unless they will give the gaseous. Okay. So that's why we will get the delta NGRT. So now here, see, we know the formula delta U is equals to what? The formula, sorry, delta H is equals to delta U plus Jaldi P delta V, right? Delta H is equal to delta U plus P delta V. So delta H is equal to delta U plus C. P delta V is what? P delta V, from here we get to know delta NGRT. So delta H is equal to delta U plus delta NGRT. Okay. So this delta H is equal to delta U plus delta NGRT. This is from ideal gas equation. This is from ideal gas equation. And when we will use here, when we will use this, we will use when we have what? Yes, when it is given, like, you know, the product is given in the gaseous and reactant is also given in the gaseous. Then we will find the delta Ng. Delta Ng means how many number of moles present in the product side minus number of moles present in the reactant side, number of moles of gaseous. Okay, like suppose here, let's suppose this. Okay, just take this as a example. So this is what? Water in the liquid form, it will convert into the water into the gaseous form. So how we will find the delta Ng? Delta Ng means number of moles of gaseous present in the product side. So in the product side we have a gaseous. Yes, we have a gaseous. How many moles? It is 1 mole. So number of moles present, number of moles of gases, number of moles of gases present in product side is 1 mole. 1 minus number of moles of gases present in reactant side. So in reactant side we don't have any gases, we have just liquid. So number of moles of gases present in reactant side is nothing. Nothing means 0. So 1 minus 0 is 1. So delta Ng in this case it is 1. So you can see delta Ng they have taken as 1. Understand how we will find the delta Ng? Delta Ng, it's very easy. We will find the what? Delta Ng, yes, number of moles of gases, number of moles of gases present in product side minus number of moles of gases, number of moles of gases present in reactant side. Okay, if reactant side is not there, we'll take 0, or if product side is not there, we'll take 0. Whatever is there, we will take. So only number of moles of gases, we will not take of solid, liquid, aqueous. No. Okay. Fine. Okay, let's see problem 5.5. See, if water vapor is assumed to be perfect gas. Okay, they talked about perfect gas. Perfect gas means what? Yes. Perfect gas means ideal gas. Perfect gas means they are talking about ideal gas. Perfect gas means they are talking about ideal gas. So if water vapor is assumed to be a perfect gas, molar enthalpy change for vaporization of 1 mole of water at 1 bar at 100 degrees Celsius is 41 kilojoule per mole. Calculate the internal energy change. Okay, we have to find the internal energy change, means we have to find the delta U. Okay, and see here they talked about water vapor is assumed to be perfect gas. So molar enthalpy change means delta H. What is given? Molar enthalpy change for vaporization of 1 mole of water. Okay, so 1 mole of water, it will get converted into a perfect gas. Perfect gas means it will convert into the perfect gas. It will convert into the perfect gas. So that's why you can see the change. Starting only they had written this change. Starting only they had written the change. See, the change is what? The water which is in liquid form, 1 mole of water which is in liquid form, it will change into water into the gaseous form, because perfect gas. Okay, so 1 mole of water is vaporized. So 1 mole of water is vaporized means here 1 mole of water means liquid form, is vaporized means what? We will get the 1 mole of gas. Okay, because water will vaporize, what we will get? The gas. So if 1 mole of water is vaporizing, we will get the 1 mole of gas. Okay, because it is a perfect gas. Okay, so see delta H, what they had given? They had given here mole enthalpy change for vaporization of 1 mole of water at 1 bar at and 100 degrees Celsius is 41 kilojoule per mole. So enthalpy change is 41 kilojoule per mole. So delta H is given. Okay, we have to find the calculate the internal energy, means delta U. So simple thing is delta H is given, so we'll use the formula. So first we'll write the change. What is given? 1 mole of water means H2O in the liquid form will vaporize and we'll get the 1 mole of water in the gaseous form, like 1 mole of vapor, 1 mole of vapor. So that's why H2O in liquid, it will give H2O in gas form. So it will remain 1 mole because it is a perfect gas. So delta H is given, we have to find the delta U. So we'll use directly formula delta H is equal to delta U plus delta NGRT. Why we are using delta NGRT? Why we will not use delta H is equal to delta U plus P delta V? The reason behind is here they had mentioned perfect gas. Perfect gas means what? Ideal gas. Perfect gas means what? Ideal gas. So that's why we'll use the ideal gas formula. So we have to find the delta U. So what will happen? Delta H and this will go that side. So delta H minus delta NG RT. Delta H is already given 41 minus delta NG, just now we find it is 1 into R value we know 8.3, that the gas constant. T temperature is given 100 degrees Celsius, but we have to take into Kelvin. So 100 degrees Celsius means it will become 373. When you will multiply this and all, you will get the answer. Simple thing. Main thing is guys, here you have to just catch the word. This word indicates that perfect gas means ideal gas. We are going to use the formula of ideal gas. Okay. Fine. After this, all the notes you have to, this example 5.5 you have to write. Okay. Extensive intensive property. Fine. Now we'll come to this heat capacity. Heat capacity. This is very easy thing, guys. This is very easy thing. Heat capacity. Okay, heat capacity. Heat capacity means what? See, by the name we will get to know. Heat capacity means if I will tell the any object, like capacity of holding the heat, right? Heat capacity means the capacity of holding the heat. Okay, so we'll write the heading heat capacity, then we'll write by arrow. This heat appears as a rise in temperature of the system in case of heat absorbed by the system. Obviously we know. So heat capacity means how much heat it can hold, the capacity to hold the heat, right? Heat capacity means the capacity to hold the heat. If his system is holding the heat, if system is holding the heat, what does this mean? System is holding the heat means system is absorbing the heat, right? System is holding the heat means what? System is absorbing the heat. If system is absorbing the heat, what will happen? Rise in temperature. So that's why it says this heat appears as a rise in temperature of the system in case of heat absorbed by the system. Okay. Now what will happen? The increase of temperature, obviously the increase of temperature is proportional to the heat transferred. How much heat transferred to the system, that much the increase in the temperature. So that's why it wants to say that this heat transferred is directly proportional to increase in temperature. Increase means what? Change. So it will be delta T. Q is directly proportional to delta T. So we have to remove this proportional sign. So what we will use? We will use the Q equals coefficient into delta T. So coefficient is denoted by C. Okay. Increase of temperature means the change in temperature. Change in temperature means delta. So increase of temperature is proportional to the heat transfer. So this how we'll get the Q is equal to coefficient into delta T. So the magnitude of the coefficient, this magnitude of the coefficient depends on the size, composition and nature of the system. So we can also write this Q is equals to coefficient into delta T, what I have written here. Okay, you can write this all the yellow color underline. C is called the heat capacity. The coefficient C is what? It is called the heat capacity. Okay. Then we will write on this, when C is large, the given amount of heat result only a small temperature rise. If this coefficient will be high, so delta T rise will be very less. Okay. Shit. I hope you have written, guys. It's got missed off the underline. Okay, fine. Now see here, C is directly proportional. C is directly proportional to the amount of substance. C is what? Capacity. Okay, coefficient. It is directly proportional to the amount of substance. So now if we will talk about mole, so the molar heat capacity of a substance Cm, Cm means M indicates the molar, C is a heat capacity. Molar heat capacity of any substance is C divided by N. N means number of moles. So heat capacity, C means what? Heat capacity. Heat capacity divided by number of mole. Okay, so Cm is what? Is the heat capacity for 1 mole of the substance, right? C means heat capacity for 1 mole of the substance. And see, this is the definition of molar heat capacity. This is the definition of molar heat capacity. So molar heat capacity is the quantity of heat needed to raise the temperature of 1 mole by 1 degree Celsius or 1 Kelvin. So we are talking about 1 mole. So that's why it's called as molar heat capacity. So 1 mole means molar heat capacity. Okay, so you can write, remember this formula. Molar heat capacity means heat capacity divided by what? Yes, heat capacity divided by number of mole. Okay, because it is for molar heat capacity, so we'll take the number of mole. So from here we will get the one formula, that is this: Q is equals to C delta T, right? Q is equals to capital C into delta T. So we know that for molar heat capacity, what will happen? Molar heat capacity is heat capacity divided by number of mole. Heat capacity divided by number of mole. So if we have to find the value of heat capacity, so what will happen here? Heat capacity C is equals to N will go here. So it will become Cm into N. Cm into N. So like this here. Q is equals to, what is this? C delta T, or we can write this C into M into delta T. Okay. C is what? C is the like specific heat of the substance. M is the mass and temperature change delta T. cm, no, wait, no, we can't change like that. No, okay guys, see here. Sorry, these both are not related. This ये both related नहीं, formula पे use होता है. Okay, fine. So here we will just remember this formula. Q is equals to C delta T, or C, if you will take the mass, means C into a specific heat into mass into delta T. Sorry, it's not the mole, it's the mass. Okay, ठीक है. So we know that the normal formula of Q is equals to specific heat into delta T. But if you will take the mass, then a specific heat into mass into delta T. Okay, this is the formula you can write. Now we will come next for the relation between Cp and Cv for an ideal gas. Relation between Cp and Cv for an ideal gas. So we'll write on the heading the relation between Cp and Cv for an ideal gas, and then we will do the derivation over here. So we'll write on the heading C, relation between Cp and Cv for an ideal gas. For an ideal gas for 1 mole. For an ideal gas for 1 mole. This is very, very important. Relationship between Cp and Cv for an ideal gas for 1 mole. For 1 mole. Write on this heading. For 1 mole means what? N is equals to 1. Okay. Chalo, ठीक है. Now see here. So Qp and Qv, they said, sorry, Cp and Cv. Okay, we know that Q, the normal Q formula is what? We will start from here. The normal Q formula is what? Q is equals to C into delta T. C into delta T. Now if you will find at this heat at constant pressure, first we will find the heat at constant pressure. So heat at constant pressure means what? Qp. Heat at constant pressure means Qp. So heat at constant pressure means it will become Cp delta T. Why? Because heat at constant pressure, so heat capacity at constant pressure and delta T. Okay, equation number चलो लिख लेते 1. Now I will write the heat at constant volume. Heat at constant volume. Why we are taking at constant pressure and constant volume? Because we have Cp and Cv. So Cp means heat capacity at constant pressure. Cv means heat capacity at constant volume. So we will write here heat capacity at constant volume. Sorry, heat at constant volume is heat capacity at constant volume into delta T. Okay, we got the equation 1, we got the equation 2. Now what we have to do? We have to find for 1 mole of ideal gas. 1 mole of ideal gas. 1 mole of ideal gas. Guys, actually it is 1 mole only. So ideal gas is what? PV is equals to nRT. So 1 mole of ideal gas means N is equals to 1. N is equals to 1. When you will substitute, it will become PV equals RT. We will get PV equals RT. So PV value is what? PV value is nothing but RT. So we will write this delta H is what? Delta H is equals to delta U plus delta U plus delta PV, because PV value is what? Direct RT. So delta PV we will write. So it will become delta H is equals to delta U plus delta PV. What is a PV? PV is nothing but RT. So in place of PV I will write this RT. Delta H is equal to delta U plus delta RT. So see, we know that R is what? R is a real gas constant. It is a constant. The constant means I will write R delta T. Delta H is equal to delta U plus R delta T. Now see, delta H is what? Delta H is nothing but, jaldi jaldi bolo bhaiya. Hare oh pyare, we can see here delta H. What is delta H? What is delta H? See here. Delta H is equals to QP. Delta H is QP. So what I will write? In place of delta H I will write QP equals delta V is what? QV plus R delta T. So QP is what? QP is this. Cp delta T equals QV is what? This CV delta T plus R delta T. We know delta T will get cancelled. So after that what we will write? After that we will write Cp is equals to Cv plus R. The relation is Cv, sorry, this will come this side. Cp minus Cv equals R. This is the relation. Cp minus Cv equals R. Okay. So this is for 1 mole. This is for 1 mole. Okay. In general formula is what? General formula is this: Cp minus Cv equals N into R. This is the formula, N into R. For 1 mole means N is equals to 1. N is equal to 1 means this. If suppose we have a 5 mole, so this will become Cp minus Cv is equal to 5 into R. Okay, this is a very important. So after the heading you have to write this, then this, and then this. This is the general equation. This is the general equation. But this is the equation for 1 mole. This is the equation for 1 mole, and this is the general equation, N into R. Okay. See here, Cp minus Cv is equal to 1. This is very small, guys. If you write this in the examination, very less chance that they will give you the marks. Okay, very less chance that they will give you the marks, because here same cheez hai na. Okay, here just they have said that putting as fine delta H and delta U value. Okay, fine. Now you can write this also. This also you can write, because here they have mentioned here. Okay, you can write this also, or you can write this mine also, because I have explained you here like how these things came. Okay, so this is for the general and this is for the 1 mole. So that's why, see, this is the main final expression what we have to write. Why? Because here you can see I have written the relationship between Cp and Cv for an ideal gas for 1 mole. For 1 mole you have to write this: Cp minus Cv is equals to R. Okay, if it is not a 1 mole, then you have to change it. Okay, because here, see, here they have said here for a 1 mole of ideal gas. For a 1 mole of ideal gas. Okay, so the Cp minus Cv is equals to R, that is for 1 mole. If the number of mole will get changed, if suppose in the option they will ask that write the relation between Cp and Cv for an ideal gas for 3 moles. Then 3 moles means you will write Cp minus Cv equals 3R. Okay, so this is the important thing. So the general equation is Cp minus Cv equals N into R. So here it is a for 1 mole, so that's a N is 1. So we'll get Cp minus Cv is equals to R. So in the examination you have to see what they are asking for 5 moles, for 2 moles, for 3 moles, for 10 moles, for 8 moles, for 1 moles. Okay, that is very important. Now we will come for the next topic, that is now we'll come for the next topic, that is measurement of delta U and delta H calorimetry. Okay, so measurement of delta U and delta H by using the method that is calorimetry. So before that we have to see here. So what you will write here, you will write, don't write anything. I hope till here you understand right how to write the derivation, and the before derivation you have to write the points which I have marked like this. You have to write the point which I have marked like this: the blue color, the green color, the blue color, sorry, yellow color, and the green color, sorry, yellow color, green color. Right here also yellow color, green color. That only you have to write, and the things what I have told here, right, the things what I have told here how to write, you have to write like that only notes. Okay, fine. Now next thing we will continue with this. So for this what you have to write, just write on this heading: measurement of delta U and delta H calorimetry. After that you have to write down from here. Okay, calorimetry and calorimeter. So first of all we have to understand what is calorimetry and what is calorimeter. So the energy changes associated with chemical or physical process. So see, whenever we do the chemical process or whenever we do the physical process, there is some change in the energy. Okay, so energy changes associated with chemical or physical process. If some chemical process is happening or physical process, obviously there is some change in energy. So energy changes associated with chemical or physical process can be measured by an experimental technique called calorimetry. called calorimetry. Okay, so calorimetry is what? It is experimental technique. Calorimetry is what? It is experimental techniques. Okay, the energy changes associated with chemical or physical process can be measured by an experimental technique called calorimetry. Okay, fine. In calorimetry, the process is carried out in a vessel that's called calorimeter, which is immersed in a known volume of liquid. Okay, so that is the thing. Okay, so calorimetry is what? Calorimetry is experimental techniques, but calorimeter is a vessel in which the process is carried out. Okay, and very important thing, guys, whatever the like calorimeter is a vessel which in which the process is carried out, this we will immerse in a known volume of liquid. So we will immerse in a liquid whose volume is known. This they can ask in the examination. Which immerse in a known volume of liquid, unknown volume of liquid, or fixed volume of liquid. It is not fixed, it is known, because volume of liquid keeps on changing, so that's why we have to measure. Okay, so it's a known volume of liquid. So now write on this heading, measurement of delta U, and by using this bomb calorimeter. So here you can see, guys, we have to do the measurement of delta U and delta H both by the process called calorimetry. So first we understand what is calorimetry and what is calorimeter. Now what we will do the measurement of delta U. Okay, so measurement of delta U by using which? Bomb calorimeter. This is very important. Measurement of delta U by using which? Bomb calorimeter. Measurement of delta U by using which? Bomb calorimeter. Okay, so now what you have to do is open this page. So here, guys, delta U measurement. Now this is very easy and very simple. First I will explain you in a normal ways. So understand here, first I will explain you in a normal ways, then I will show you the notes or the working. Okay, see here. So what will happen? This is a bomb calorimeter. This whole setup is called bomb calorimeter. Okay, so now what will happen here? I will take this bomb. Okay, I will take this bomb. Its name is bomb. I will take this bomb. Okay, and then in the bomb, what I will do? I will fix this oxygen inlet. So what will happen? From here I will supply the oxygen. So what will happen? This bomb, in this bomb I will I will take this. Okay, that's what you can say. You can say the piston type or anything type. Here I will take. Okay, we have here oxygen inlet. So what is the work of oxygen inlet? We will supply the oxygen. Why we want to supply the oxygen? Yes, we will supply the oxygen, so that's why there is a proper combustion, right? Burning in the presence of oxygen is called combustion. So what will happen? We will take a bomb and then we will supply the proper oxygen here, and inside the bomb we will take a sample. This is a sample. Inside the bomb we will take a sample, and then here this is oxygen under pressure. So what will happen? We will fire it. See here, firing leads. We will connect the sample with what? With the firing leads. So what will happen? We will fire the sample. We will burn the sample. So what we will do? First of all, we will take the bomb. In the bomb we have the oxygen inlet. So that's why we will supply the oxygen, proper oxygen inside the bomb. Why we want that proper oxygen supply inside the bomb? The reason behind is, inside the bomb we will keep the sample. And this sample we have to burn. So burning in presence of oxygen is called combustion. So here we want a proper burning. So if there is a lack of oxygen, the burning will not take place. This is a very important, guys. 110% you can assure that they will ask in the examination. They explain the bomb calorimeter. or explain the measurement of delta U. Okay, by experimental technique like that they will say. Okay, so what will happen in the bomb we have the oxygen inlet from where we will supply the oxygen. Why we will supply the oxygen? The reason behind is in bomb we will take a sample which we have to burn the sample. What we have to do? We have to burn the sample. So when we have to burn the sample, we want the complete combustion. We want the complete combustion. So how the complete combustion will happen? Because the presence of proper oxygen. So that's why we will supply the oxygen through the inlet. So what will happen when this sample will burn inside the bomb? So what will happen when burning will increase the temperature? Burning will increase the temperature. So that's why the bomb is dipped inside the water. You can see this, all the water, the bomb is dipped inside the water. So what will happen? Before the water temperature is normal. Before the water temperature is what? Normal. So when bomb starts, sample starts burning inside the bomb, right? So what I did, bomb, in that bomb I will bring the sample and I will burn the sample. So for the complete combustion of sample, we have an oxygen inlet, we will supply the oxygen. So that's why the sample will, the burning of sample is called like a complete, it is a complete burning of sample. That's we call the complete combustion process will happen. So that's why when it is a burning inside the bomb, so the temperature will increase. So before the water temperature was normal. So now inside the bomb the temperature will increase. So that's why we have dip the bomb inside the water. So what will happen when the temperature will increase? This temperature will go to the water. 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 So what will happen? As the temperature inside the bomb is increasing, it is get spread into the water. The temperature will get spread into the water. The temperature will get spread into the water because this bomb is dipped inside the water. The temperature will spread into the water. So that's what will happen here. Before the temperature of water is very less, after the burning, what will happen? The temperature will get released to the water. The temperature will get released to the water. So that's why what will happen? Now the temperature of water is increasing. Now the temperature of water is increasing and we kept the stirrer over here. So we have to rotate the stirrer. So what will happen? The temperature will not be at one place. The temperature will get, the heat will be not at one place. The heat will get distributed in all over the water. We will on the stirrer. So what will happen? The heat which is coming out from bob, the heat which is coming out from bob, which heat is coming out from the bob? Joldi bolo. Yes, the heat which is coming out from the bob is the heat which is produced by the burning of sample. Okay, so that heat, it should not get placed at one place of the water. So that's why we'll on the stirrer. So that's why the heat will get uniformly distributed over the water. So when the heat is get uniformly distributed over the water temperature will increase. So that's why we have a thermometer dipped in the water to calculate that how much temperature of water is increased. How much temperature of water is increased. And then this, all the things we have kept in this isolated system. So that's why isolated system. So that's why what will happen? The heat is not going outside. The heat is inside only. Okay. So once again I will tell you what we will do. First of all, we will take a bob. Inside the bob we will keep a sample. This is a working. First of all, we will take a bomb. Okay. Inside the bomb we will keep a sample, and this sample we will burn the sample. So what we will do, first of all, we will take a bob. Inside the bob we will bring a sample and we'll burn the sample. So burning, we want it should be complete combustion. So that's why we will supply the oxygen through the oxygen inlet. So when the burning will happen in the presence of oxygen, it is a complete combustion. So when the complete combustion burning is happening, what will happen inside the bomb? The temperature will increase. So that's why we will dip the bomb in the water. So that's why the temperature which will be coming out from the bomb, it will go to the water. So before the temperature of water was normal. So what will happen, as the heat will get coming to the water, the heat is coming to the water, what we will do, we will on the stirrer, so that's why heat will get uniformly distributed into the water. The heat will get uniformly distributed into the water. And now what will happen, as the heat is getting uniformly distributed into the water temperature is increasing. So how much water temperature is increasing, we will dip the thermometer, so we will calculate the rise in the temperature, so we will find the temperature increase of the water. And this all the things is happening in the closed insulated, okay, closed insulated this, so that's why the heat will not go outside. This is the process of the bomb calorimeter to find the change in the internal energy. Okay, so I hope you understand. So we'll see the this theory over here, which is very important. So what is bomb? Bomb is a strong sealed metal container. Okay, sealed metal container means usually made of stainless steel that can withstand high pressure. The bomb is what? A strong sealed metal container. Okay, this is the bomb, a strong sealed metal container, a strong sealed metal container. Okay, contains the sample to be combusted and excess oxygen. So it will contain a sample to be combusted at excess oxygen. So we will supply the excess oxygen. Why? Because we want a complete combustion. Okay, so bomb, and then in that we will have sample. So oxygen supply, obviously pure oxygen is supplied to ensure complete combustion of the sample inside the bomb. Okay, then next is water bath. Water bath, this is the water bath, okay, in which the bomb is dipped. Water bath means the bomb is submerged in a water filled jacket, or you can say insulated container. What I have said, the container is insulated to observe the heat released by the combustion. The heat released by the combustion through the bomb, so that water will absorb the heat. Stirring mechanism, it ensures uniform temperature distribution in water to get accurate temperature readings. It will stir means what will happen, that heat will get uniformly distributed over the water, so that we will get the accurate temperature readings. Now thermometer, we know that thermometer or temperature probe is used to measure the temperature change of water, that how much temperature got changed, means how much heat is absorbed by the water. Insulation means the entire apparatus is insulated to prevent the heat loss to the surroundings. So this is what the insulated, this is the insulated, so it will not allow the heat to pass. Okay, then yeah, so working is this very easy working. If you will read the working also, you will understand the working. See, working is what just what I have explained. So what you have to do here is, after writing this heading, you have to write this calorimetry and calorimeter. Then after that you have to draw the structure. After that you have to draw the diagram. So not the structure, you have to draw this diagram. You have to draw this diagram, then do the labelings. You have to draw the diagram, do the labelings. Okay, so you have to draw the diagrams. You have to draw this diagram, do the correct labeling. Okay, because in the examination labeling also give you the marks. So draw the diagram, do the correct labeling. After that you have to write from here measurement of delta U, bomb calorimeter, this part, bomb, then oxygen supply, then water bath, then stirring mechanism, then thermometer, then insulation, then working. So if they will ask the working, so then working means you have to draw the bomb calorimeter figure, the diagram, and then you have to write down the working. If in examination they will ask the definition, you have to write the definition: insulation, thermometer, stirring mechanism, this water bath. Okay, working means the sample is ignited which undergoes complete combustion, right? We will burn the sample which will go under complete combustion and release large amount of heat. So what will happen, this increases the temperature of the bomb and the surrounding water in the calorimeter. Since the bomb calorimeter is sealed, its volume does not change. That is mean the energy changes associated with reaction are measured at constant volume. The volume will remain constant, delta U. delta V, sorry. The temperature changes of water is recorded with thermometer during a reaction, that is called delta T, change in temperature. So whatever the heat released during the combustion will be equal to, heat release means what? At constant volume means delta U. Delta U, that is nothing but minus CV delta T. That's it. Okay, because see what we know already, we studied at constant volume is what? Change in internal energy, because we have to find the constant volume. At constant volume, the constant volume is change in delta, change in internal energy. So qv what we have studied, qv we have studied is cv delta T. So we'll take the minus cv delta T. Okay, why we are taking the CV, why we are taking minus? The reason behind for taking the minus is, yes, there is a means what you can say, decrease in the temperature, because the temperature will get out here, right? The temperature will get outside to the water, so there is a decrease in the temperature. Okay, see here. So what will happen? The heat lost, so that's why they have taken minus. Okay, heat lost means minus. How the heat is losing? Because from the bomb the heat is going outside to the water, and it will get uniformly distributed in the water, so that's why bomb is losing the heat. Okay, because the heat is going exothermic, exiting from the bomb. Okay, so that's a heat loss means minus. So the formula is this, you have to write down this whole till here. So this is for the today's class. In the next class we are going to continue this part, delta H measurement. Okay, we'll continue the delta H measurement. So delta H measurement will happen at constant pressure. So pressure will remain constant. This is not much important for the examination, but we will see. Okay, so in the next class after that we'll solve the problems also. The problem is very easy. If you will try, you will get the answer for the problem, because we get to know the formula Q is equals to minus CV delta T. So we'll substitute the values and then we will get the answer over here. Fine, no worries. This in the next class we'll continue this delta H measurement, and then this we'll solve the problem, then we'll move on the different enthalpy this reaction. Okay, enthalpy change of a reaction means reaction enthalpy, what it can happen. Okay, like a standard enthalpy change during phase transformation. Okay, so this will continue in the next class. So I hope you are understanding the concept, and it's very easy thing. Okay, so yeah, I know the thermodynamics will be a lengthy chapter, and after that equilibrium will also be lengthy, then organic chemistry will also be lengthy. So first of all we'll cover up those chapters, then we'll move on for the next chapters. Okay, because before the examination we'll cover up all the syllabus of the your 11th standard chemistry, including the example problem and the exercise problem also we are going to solve. Okay guys, thank you, bye bye, we'll meet in the next video.